All right, this is the video for section 3.3 notes, slide number 13. All right, so we're finding dy dx. All right, so y equals the natural log of the absolute value of x cubed plus 3x plus 1. Right now, notice you have an absolute value here, but as we said earlier, that the existence of the absolute value does not play a role in the derivative. All right, so we want dy dx equals. All right, so remember the rule for the natural log of u is 1 over u, so x cubed plus 3x plus 1 times the derivative of u. So what is the derivative of x cubed plus 3x plus 1? That would be 3x squared plus 3. Right now, remember, we should put this in parentheses so that it does get multiplied by that entire thing, but we would probably just put this into the numerator and rewrite it as 3x squared plus 3 over x cubed plus 3x plus 1. All right, now it's also possible that you could factor out like a 3 in the numerator, but that's just fine. All right, so pretty simple, right? All right, now natural log of x over x. All right, so now we have to realize that we have a quotient. All right, so dy dx is going to use the quotient rule. So the quotient rule, remember, says the denominator, so x, times the derivative of the numerator. So derivative of natural log of x would just be 1 over x times the derivative of x, which would just be 1. So we usually don't even write that. All right, and then minus the natural log of x, numerator, times the derivative of the denominator. What's the derivative of x? That's just 1. All right, and then all divided by the denominator squared. All right, and so now we might just simplify this a little bit. X times 1 over x, that's just 1, minus the natural log of x over x squared. All right, so that is slide number 13. Just a couple extra examples of using the derivative of the natural log of x.